So hi everyone, this is Nikhil and welcome back to video series on how to design this particular model aeroplane, that is Concorde, and this will be the part 2 of the week 2 series. So let me just begin and let me briefly tell you about the small design changes that I have made. So this is the wing which we designed in the last video on part 1, and as you can see I have added a little taper on this particular joints which will be used to join this particular wings to the fuselage or the main body of the aircraft. If you see it from the end side view, there is small taper and this will help us in inserting this particular wing onto the body. So I have discussed in the last video that we will be using interference fits to be able to firmly fix the wing so that it will stays in its place and it will not be loosened out. So I will go into much more detail about these fitted joints in part 3, but for now we will see how you can design the main body of this plane, which is a bit complicated. But let me also introduce you to something known as form. Okay, so this is a new feature which is exclusively developed inside of Autodesk Fusion 360. This is a very powerful tool that is known as create form, and as you can see this allows you to freely freeform objects, and this feature is also available in CATIA and Siemens NX also, but they are a little bit costlier versions of software, but they are not free for students, and hence I highly recommend you to try and get this Autodesk Fusion 360 which is free for students. And I am also in regular follow up with Autodesk themselves so that they can provide you with licenses even though you are not registered as a student. So we'll see about that later. I am actually working to establish my trainings inside of Autodesk Design Academy, from which you can also watch these videos. We'll see how things pan out, but for now, let's focus on what we are doing in this particular video. So, inside of this extrude feature, there is something known as taper angle, and you can see I have given a taper angle of 5 degrees. So, if you see it from the end, this is the particular rectangle which I drew for extruding it onto this particular wing. So let me just cancel this and show you what the exact sketch that we have drawn in the last class. This was the particular rectangle of length 40 mm, which is of 30 mm distance from this particular y-axis, and it has a thickness of 1.6 mm. I reduced that to 1 mm. I will come to that just a little bit later. And let me click on finish sketch, and let me go ahead and walk you through this particular command. And here you can see direction is one side, start is profile plane, object is this one. So if you are selecting something else, let's say if I cross this particular sketch is being extruded towards right hand side, and if I want to extrude it towards left hand side, I can simply bring this down arrow, and as you can see it is being extruded and at the same time it is increasing in its particular thickness. That's because I have given a taper angle of 5 degrees. Let's say if I gave a taper angle of 1 degree, this is how it expands. Let's say if I give a taper angle of 20 degrees, it is getting expanded like this. So I'm just trying to explain you how this particular command works, that is known as taper angle. And one more challenge is that instead of distance you can also use to object. So I will come to what is meant by this two particular object. I will click on this particular object selection and click on this, and it's showing me error because if you are extruding some sketch onto a certain body, then it needs to be exactly intersected within that body and it should not come out of that body. So I will reduce this particular taper angle. I don't want such a huge taper angle, and let me give just 5 degrees, and let me select this particular object and let me drag it towards, and now you can see it is generating an error. Let me see. There is a small box kind of a thing. I hope you can see this. Beside this particular arrow, there is something known as select body, face, plane, or vertex to extrude to. I will click on this and say this one cannot complete extrusion. Okay, let me try and reduce this particular angle. Let me try to zoom in and I will select this particular face. Okay. So it is asking me to select the face. So that's the thing where I made the mistake. So if I select that particular face, it is extruding me only till that particular face. Let me extend this bodies and click on this particular body. And if I click on the whole body, it is getting extruded to the whole body. So now if I go to this particular view, you can see that this particular extrude option has extruded into this particular fillet area as well. So that's exactly what I want. And I want to give a little more taper angle of 5 degrees. Let me enter that. And you can see that the taper angle has increased. And now I'm happy with this design and I will click on OK. And that's how you can build the tapered joints. So now let me go ahead and save this. And now I want to create the body of the aircraft. We have already created this particular horizontal canvas previously in part 1, and now I want a particular canvas onto the vertical plane and also on this particular plane. So for that I will again go to insert and I will click on canvas, and I have uploaded this particular JPEG image onto Fusion 360. So if you want your files, you can also click on this particular upload button and upload your design files. And I have these images which I downloaded. So whatever image you want, you can simply click on that and click on open, and it gets uploaded inside of Autodesk Fusion 360 Cloud. So I will click on insert, canvas. Let me select this particular image, click on insert, and it is asking me to select the face. I will select this particular plane and it got inserted. You can see it is very small and it's also tilted. So for that I will go ahead and go down and say horizontal flip or vertical flip. See, for this particular image, the nose of the aircraft is pointing backwards. I want to flip this image and I will click on flip horizontally. Now you can see this particular image got flipped up and this is now aligning in its perfect direction. So if you need to scale this up, you need to use calibrate. So I will click on OK here, and you can see on this left hand tree, you can see one more canvas that's being added. So I will right click on this and say calibrate. And I want to go to the front view. And I want to click on a particular point on the nose of the aircraft. Let me zoom in with my mouse wheel. And I will click on this particular point, which is the end point of this nose of this aircraft. And I will again zoom out and again zoom in, placing my cursor at this particular endpoint. And I will pick up a point here. And now it is saying me 11.28, 11.989 some mm. So as we discussed in part 1, the length of our aircraft is 180 mm. So let me hit 180 and enter. And after you hit 180 and enter, you can see that your aircraft image is now scaled up. Click on the home view and you can see you have two planes. One is horizontally and another is vertically. And I'm okay with this particular thing, but you can see that the wing is not aligned. This is our wing, but our image is not aligned properly. So for that again, I will click on this particular canvas, right click it and say edit canvas. After I click on edit canvas, you can see these particular handlers, and with this particular arrow handler, I can move this particular image so that it gets aligned perfectly with the wing. If this particular image does not get snapped up perfectly, please try to observe. If it is above the wing, it is showing minus 10 mm. If it is below the wing, it is saying minus 20 mm. So let me enter minus 15 and see what happens. Minus 15 is also very well above. So let me enter 18. And I guess now this is fine. Let me enter 19 or 17. Okay, let me enter 19. and this particular level looks fine for me, and I will click on OK. I will drag this particular thing and click on OK. And now I will save this so that I will not lose my changes. And now you can see that the blueprint or the background image to develop the body of the plane is exactly in its place. Now, in order to avoid confusion, you can simply hide this particular canvas and start your design, and whenever you want, you can on them to refer yourself. So now what I will do is, as you can see, this particular body of the aircraft is in perfect cylindrical shape, and only the nose part is in conical shape, and only the tail part is in conical shape, and the rest of the body which is there in this particular middle is perfectly a cylindrical object. So what I'll do is, I'll first design this particular cylinder, and later on I will design the nose and the tail of the aircraft, and finally we'll also design these engines, wheels, as well as this vertical stabilizer. Please don't call this as a tail. If you are an aerospace engineer or an aeronautical engineer, you should be able to technically describe this particular aircraft. If this particular aircraft has only one wing and it does not has a horizontal stabilizer, such an aircraft is known as delta winged aircraft. And what you are seeing on the vertical side is known as vertical stabilizer, and you will have your rudder, which is the control surface for controlling the. There are three main axis systems about which the aircraft gets controlled. One is the pitch control, another is roll control, another is yaw control. So this particular rudder gives you the yaw control, which helps the aircraft in turning. And if you want to make a separate video course on flight dynamics, I can also do that, because I have also studied flight dynamics as my side subject while I was in college. So I can also explain you that. But for now, let's just focus on making this particular model aircraft. So I want to start my sketch on this particular plane. So what I'll do, I'll click on this create on menu, click on create sketch, and select this particular plane. And now let me go ahead and create and click on circle, and let me start my circle somewhere here and draw a circle like this and click on finish sketch. Before going to finish sketch, I want to give certain dimensions. Let this be 15 mm and let the height of this be 5 mm for now. We will edit them later, but for now just focus on this. And now I want one more canvas onto this particular plane. For that I will go to insert, canvas, and again in canvas select Concord blueprint, click on insert, click on the face, see if it's aligned properly, click on OK, hide the existing canvas, and it is too small. So onto this particular plane, we want this particular image, which is the front view of the aircraft. So I want to move this to its center, and I also want to calibrate this. So how will I calibrate? I don't know what is the exact width of this particular model aircraft. So what I'll do, because we have already modeled these wings as per the image and we have calibrated it according to the length, then automatically the wingspan will also get calibrated. So the width between tip of the left wing and the tip of the right wing is known as wingspan. These are some of the technical terms which you need to know if you are an aerospace or an aeronautical engineer. So for that, let me go back to this particular sketch of the wingspan, and you can see that there is 4 mm gap between the central axis and the root of the wing, and the wingspan is 32 mm. So 32 mm plus 4 mm is 36 mm. So that is the width or the total length of this particular wing from its wingtip to its root. So this is another term which you need to know. This particular line which is getting highlighted is known as leading edge. This particular line of 10 mm length is known as wingtip. This particular lines, these two lines are known as trailing edge, and this particular line is known as root of the wing. Okay, and this particular extension is known as leading edge root extension, and this is used to develop airflow vortices which will delay the flow separation when your aircraft is taking off. So that's the aerodynamic part. If you want, I will make a separate video series on aerodynamics as well. So now with this particular sketch we can come up and know that our wing is of distance 36 mm. So I will click on finish sketch, click on the home, and again right click on this particular canvas and click on calibrate. Go to the right hand side view, zoom in a little bit, and I will click on 2 points. One is the leftmost point of the aircraft wing and another is the rightmost point of the aircraft wing, and this length should be 36 plus 36, which is 72 mm. And now this is calibrated perfectly, and now I need to move this accordingly. I will move this image perfectly in its center, and you can see this is minus 90 mm, this is minus 80 mm. Let me try and give out minus 85, minus 84, minus 83, minus 83.5. This is how you need to fine tune your distance so that it becomes a perfectly aligned object. And I'm fine with the distance, and let me bring this down, and minus 20 mm and minus 15 mm, it is getting snapped like this. So let me give minus 18 mm, and now this is looking perfectly fine. Probably I can give minus 17 as well. Let me check. Minus 17, minus 16, minus 17. I will give minus 17.5. What my intention is, these wings should be intersecting with the body of the aircraft. If you don't have a perfect overlapping with this particular circle which I have drawn here as well as the wings, then when you insert the wings, the body of the aircraft gets disturbed and it may break. That was the main concern for me, and that's why I'm fine tuning the level of the wings. And this looks perfect for me, and let me click on OK. And now I can go ahead on to this particular sketch again. I'm not able to see this particular canvas, so I will move this ahead. And let this be 12 mm, and let this height be 3 mm. I will try to make this 11 mm. I want the body to be slightly larger than this particular image so that the wings which we are trying to attach will be very much firm in their place. So now I am happy with this particular cylinder arrangement, and I will click on finish sketch. And now I will hide this and unhide this. As you can see, this is the location, and I want to extrude this. Right click on the particular sketch and click on press pull. Press pull will extrude your particular sketch by default. So now when I try to extrude, it is removing the material. Whenever your sketch is removing the material, it shows you in this particular hidden red color. So you can see on the right hand side menu, the operation is being cut. I don't want the operation to be cut through. I want the operation as new body. As you can see, if I give join, this becomes a whole body, and these two things will get joined. I don't want to join them, but I want them to be as a separate body, and hence I want to give this as new body. You can also give this as new component, but I'm not interested in creating components, but I'm interested in creating new bodies. And when you go to large assemblies, you will know what are the components and you will know what are their subbodies in more detail. For now, I'll choose new body. Go to the side view by clicking on this cube and see how far I am extruding. I want my cylinder to be extruded up to this particular location where the nose is starting to distort a little bit. So till now, the flight is, the body of the aircraft is straight, and from here, the nose starts coning downwards. So I will create a separate cone here from this particular location. But till then, it is showing me about 100 mm. And on this particular menu, I will also choose two-sided extrusion, and I will also extrude the same sketch onto the other side as well. So up to minus 20 mm I can extrude, and from here this particular decreasing cone is starting. So I'll click on OK, and I will see how this is looking like. So I will hide this one, and if you see this, and I will also hide the origin, and now you can get a feel of how your aircraft is being built. This is the slot where the wing gets attached, and this looks very simple, but it takes a hell lot of time to design every detail of this aircraft. But don't worry, I will show you each and every step till the model is complete. I will make the third part on the fourth part. Please don't feel bored, because this is exactly what you are going to do if you join a 3D printing industry. So one more thing which you can observe here is, if I click on the bottom view, these joints are being exposed, and hence I want to develop a form body which can provide a small basis for joints. If you can see, and if I try to hide these bodies, there is a belly. This belly is nothing but the fuel where the aircraft stores its fuel. There is a small belly kind of a structure which you can observe. We need to design that. So this is a new feature which we'll be seeing now in this particular video, which is known as create form. Let me save this properly and wait till it's saved. Let me wait till it gets saved. Now my design is saved, so I can make changes. So what I was discussing is to design the belly of the aircraft. So I'll click on this create form, and inside create form you can see various options which are not directly available, or you might not be familiar with these kind of freeform objects when you tried designing something in your college days. This is nothing known as freeform, which is also available in CATIA NX, but those are very costly softwares which cannot be afforded by students. Hence we started this course using Autodesk Fusion 360. Now there are various forms here like box, plane, cylinder, quad ball, face, and modify. I want to click on box, and I want to select this particular horizontal plane, and I want to draw a small box starting roughly at this particular location. So let me go to the top view, and let me pick a rough center. This is the center where we have developed these joints. So let me click on that and draw a simple rectangle by dragging my mouse. And we need to surpass the root of this particular aircraft, which should also be slightly having more width than the wings themselves. And now when I click on that, I get this particular thing. And now I'll go to home view and I will see what is the width. I want the width of the belly to be roughly around 3 mm in size. Three and a half mm looks fine. And I will click on OK. And I will also try and visualize how this is looking to me. And then finally I will click on Finish Form. After I click on Finish Form, you can see there is a particular body which is being added. And now I'll right click on this and try to move it downwards. As we created this particular box on the horizontal plane and we have wings extending downwards, we need to move this particular body a little bit downwards. So I will right click on this particular body for click on copy or move and slightly move this downwards. So I want the belly of the aircraft to be roughly at this particular location. And once I'm happy, I'll click on OK. And now I will join the belly with the body of the aircraft. But I will join it only later because I still might need to modify this. I will hide the canvas and show you how this actually looks like. You can see that the belly of the aircraft looks perfect now. That's exactly where the fuel of the aircraft is stored. And you can now also observe that the wings which we have tried designing and inserting into this particular fuselage are also being supported by this particular belly of the aircraft. And we need to extend this belly a little bit towards the front. So what I'll do, I'll hit on escape and click on this particular body 4, give it a right click, click on move, go to the home view and extend it or move it slightly forward. Let me click on OK. And now you can see that this particular belly of the aircraft is attached in this particular fashion. So now I'll try to join these two bodies by using modify and go to combine. By using this modify combine option, you can combine two or more bodies. I will combine body 3 with body 4. And operation, I can choose either cut or intersect. I'll click on join. And now this becomes an integral part of body 3 itself. And I wish if this particular body is extended a little bit towards the tail side. So I will click on this particular edit canvas or the edit form. Click on the home view and try dragging this backwards. So I'll click on this particular thing and we'll go to symmetry. This symmetry will make you that the body becomes symmetry on both the ends. I'll click on any two faces which makes the whole body symmetry about that particular location. So now I'll click on this particular edge, right click it and click on edit form. And now if I try to pull this up, you can see that the form is getting adjusted or extended. I click on cancel because I want both the edges to be extended equally. Let me click on this particular point and try to extend it backwards and see what happens. And this particular freeform allows you to extend these bodies as you like, and that's the freedom of Fusion 360. You can see how this particular thing got extended in a very smooth manner. I'll click on OK. And then I'll click on finish form. And now if I see how the bottom looks like, you can see that this particular belly got extended a little bit. And now what I can do is I can cut slots into this particular fuselage. So what my plan is, I will try it out with exact dimension cuts, and if it is a little bit loose, I will try out by modifying the design. So I will explain what is meant by clearance fit and what is meant by interference fit. Let me open Paint and try to explain it to you. So in the last video we have seen there is an object like this. Okay, so let this be the top view of the body of the aircraft. And let this be the body of the aircraft or the wing of the aircraft. This is the wing of the aircraft, this is the body of the aircraft, and this is the joint. So let me remove the lines so that you will understand it better. So if you want to insert one object into another object, you might need space in between sometimes, and you might not need the space sometimes. So I will explain you that a little bit. If the hole is larger than the shaft, then it is known as clearance fit. In mechanical terms, a hole is any object which is used for assembly and which needs a mating part. And in mechanical terms, a shaft is any part which is being inserted in the hole. So this is a very general term used in mechanical engineering, and it always need not be circular in nature. And this particular body, which is the main fuselage of the aircraft, is hole, and the joint is acting as shaft. So if you open any metrology textbook, you will find shaft and hole terminologies in most cases, but they will never explain these particular examples, and that's the reason students find it very difficult to understand. So here, this particular gap is known as clearance. And also this particular gap is known as clearance. So what is the exact purpose of this clearance? So generally, these particular parts, if they are moving in nature, you will use lubricants. The lubricants offer special thermal and mechanical and operational properties which helps in reducing the friction between the moving parts and also act as the coolant to reduce the heat. But as we are not worried about frequent removal of this particular joint, we will make it as a press fit kind of a structure. Press fit is a type of interference joint. So that means the clearance is absolutely zero, or you can say the clearance is also sometimes negative. So in the last video, I have drawn an object like this, and I told you that if you need a particular part, you can make joints in this particular fashion. And I have also told you that this particular width can be all smaller than this particular width. And in last video, roughly I said that if this is 2.5 mm, this can be 2.6 mm. That means there is an interference of 0.1 mm. So how do you know that this particular 0.1 mm of interference exactly makes this joint fitting? So that's why I am telling you that we will first experiment with these particular interference values, and only then we will 3D print this particular whole aircraft. So what my plan is, I will first make the clearance as 0 and design a basic part, and I will not 3D print it, but I will 3D print a small sample of this particular object like this. I will 3D print this particular small sample and see what best fits this particular joint. If a 0.1 mm of interference is fitting properly, I will go ahead and modify my design accordingly. If I need more interference, I will design and modify it accordingly. If interference is not required, what I will do is, I will simply create a clearance and stick this particular wing using some glue or using some Fevicol. So you might argue by saying that using Fevicol is a very cheap method to create joints. I completely agree. But what we are doing is we are 3D printing and trying to reduce the cost so that the customer gets this model at the less possible cost. So that's our objective. That's why it is absolutely fine if you use Fevicol to join these particular joints. But you need a perfectly firm joint. You need to engineer, you need to master these particular interference fits, clearance fits, and you should also know what are the manufacturing tolerances. Those are actually dealt with by very large scale molding industries where their entire full-time job is exclusively dedicated to engineering metrology itself. But as we are starting it out as printing small models to our customers at very low cost, we will experiment this, and as we increase our expertise, we will slowly enter the spaces of plastic injection molding where we will be dealing with these particular kind of interference fits and tolerance limits. So what I'll do, I will try to create a slot by using body cut method. So for that, go to modify and click on combine, and here there are two options. What is target body and what is tool body? Let me explain that by using paint itself. Let me save this image. And I will open a new drawing. So we have a body and we have a wing. And we also have a joint which is protruding like this. So this particular region is duplicate in nature, or you can say it is being overlapped. This particular region is common for both the bodies. So I don't want that. I want to create a slot inside this particular body so that you can get a cavity where you can create this joint. So how will you create that cavity? There is an amazing feature in Fusion 360 known as body combine, and you can choose which part as the target body and which part as the tool body. So in Fusion 360 terms, this is known as target body and this is known as tool body. So using the tool body, you will cut a slot inside of target body and then you click on retain tools, or you can say keep tools. So what we are trying to do is, I want to remove this particular material which is being highlighted. I want to remove this particular material inside of the body so that I will get a cavity. And at the same time, I also want to retain this particular body. And at the same time, I want to retain the tool. In order to avoid confusion, let me use two different colors. This target body be red color and let the tool body be in blue color. So now you are getting an idea of what is actually happening. I am cutting the target body using the tool body, and the red color portion will get removed and the blue color portion will be retained. So this particular area remains, this particular area remains, this particular area remains. The blue color area which is belonging to the tool body also remains, and only the target body will be removed, only in this particular region. So I will show you this inside Fusion 360 now. So now I will click on target body as this body and tool body as this particular wing and also as this particular wing. And inside here operation is join. I don't want this to join, but I want it as to cut. And again in cut operation, I want to click on keep tools. And then I will click on OK. Now you can see, if I try to move this particular wing, let me rename this as right wing, this as left wing, and this as fuselage. In aircraft terminology, the body of the aircraft where the passengers sit is known as fuselage. So now if I right click on this particular wing and try to move it, you can see that there will be a hole that is already being cut. You can see how this hole has neatly been created for us. I'll try to zoom in. You can see this particular slot is being cut through this body. And a little support structure also got created for supporting the wing root. This is a small cavity which is cut inside the body to support the wing root and help in its securing position. You can see how awesome this is with all the fillets. There might be a small problem with the fillets, but I will reduce that shortly. So now I will click on cancel and edit this particular fillets. For that, I will right click on the fillet and I will check at what locations have I given fillets. So all these fillets are fine. I guess this is the fillet where all the edges have been selected. I will remove the whole selection set and again start selecting them. I will try to delete this particular fillet. This feature is referenced by other features in the timeline. Are you sure you want to delete? I'll click on cancel. I will try to delete it. Let me see what kind of error am I getting. And let me also delete this. And let me see what kind of wing am I getting. So the whole bottom fillet got removed. At the same time, I want to remove the whole upper part. And now you can see the wing is perfectly flat without any fillets. And I will save this design and give new fillets. And now let me remove or move this particular wing and see how the cut operation has performed. Now you can see the cut operation looks a bit perfect now. I will not give any fillets for this because this is looking perfectly fine. And later on, once the whole project is done, I will see if there are any unnecessary sharp edges and I will give fillets only at those particular locations. And now I am happy with the body as well as the wings. That's it for this today's video, and I will upload the next part 3 video regarding how to make the tail, how to make the nose, and how to make the wheels. The wheels will be on part 4 and the tail, the nose and the vertical stabilizer will be on part 3. Thank you very much for watching, and please comment below if you have any doubts, or please comment below if you have not understood any part of this video. Thank you very much. Please subscribe to the channel to get instant updates and hit on the notification bell icon.